Hello everyone, hope you're doing good and welcome back to my channel. Today we are at day 18 of the daily Leetcode challenge for the April month of 2024 and we have a question on the easier side. This question actually revolves around the topic of matrix, and to be specific, it involves the traversal technique as well. You can use the DFS or the BFS approach. I know you will be thinking that DFS and BFS are related to graphs. Okay, in this case, this is not a graph. This is a 2D matrix event was, but still the kind of way we are doing the traversal, you can call it as a DFS or a BFS, right? So this is another way of interpreting the same. So I've given you a list of what all I am going to use in this particular question. Okay, it's a DFS or the BFS approach. So if you're not sure what these approaches are, still you can continue watching this video because they are just approaches. I'm not going to, as such implicitly using them. Just for your namesake, if you are, already knowing these topics, you can relate better. That's why I'm, just giving you a hint. As simple as that. But if you are not knowing them, there is no harm. Still, you can continue watching this video because in this video, I will show you the solution from scratch. Okay. After implementing, you will realize that yeah, this is something related to DFS. Before that, you won't be realizing the same. Okay. So let's see what the question is. 463 island parameters. Okay, so you can see this image once. What we are doing here is we are given a land basically. Okay, and the rest of all the all the indices in this particular matrix are filled with water. You will have to find the perimeter of this particular land. Okay, now let's see the question. We are given a row into column grid representing a map where grid of I and j is equal to 1 represents land and grid of ij is equal to 0 represents water. Okay, grid cells are connected horizontally, vertically, but not diagonally. Okay, grid basically means land, right? So in okay, grid basically means the whole 2D matrix event was the lines are basically connected through vertically, horizontally, and also diagonally. The grid is completely surrounded by water. You can assume that. Okay, and there is exactly one land. Okay, there is exactly one island, one or more connected land of cells. Okay, this is exactly one island. See, this is the important part now because your approach will change if this is not the case. Okay, so there is exactly one island. Okay, the island doesn't have lakes. Okay, you can ignore this part. This run make much sense now. Okay, you can just see here the grid is rectangular, width and height doesn't exceed 100. Determine the perimeter of the island. So as you can see, they've already mentioned this point that the this part, the row and columns are at max going to be 100. Okay, you'll have to find determine the perimeter of the island. Okay, in this case we have to return the perimeter. So you can see in the image the yellow part actually forms the perimeter of the region, right? We have to return that perimeter. Okay, how to do this question, let us see now. First of all is the discovery part. So this is the discovery part. That means first of all I will discover where the the land area begins with. Okay, so what I'm doing here, see, first of all I will declare this. Okay, perimeter is equal to 0 and is equal to the length of the grid. Okay, this is basically the number of rows and this is basically the number of columns. Okay, I've also declared a set visited, so ensure that I do not visit them again. See, there are hacks for that. Okay, you can also make the cell as 0 after you have visited it, so you can avoid using this data structure. I've already given you this hint. Okay, so anyway you can do that, but in this particular solution I have not changed that part. I'm using in the visited part only as of now. Okay, but in the coming days you will see me using the other parts as well, right? So let us see this now. So what I'm doing, I'm going through each of the elements of the 2D matrix. For that I'm using two for loops. Okay, one inside another. Then if grid of I and j is equal to 1, okay, that means I've located the first island. Okay, I'm calling this function and passing I and j as the parameters. Then I am breaking out of this for loop. Okay, so rest everything happens inside that function only, and finally I'm returning the parameter. Okay, so let's see what is happening inside the function. Okay, this is the function and this is finally determining my answer. Okay, every calculation is done here. So let us see this. By the way, this is a recursive function. That means inside the function I'm again calling this function. So let's see what we're doing now. Okay, so see here the idea is very simple. Okay, if I is not in the range n and or j is not in the range m or grid of I of j is equal to 0 to 0, that means simply return 1. Okay, that means simply return 1. Okay, so what is happening is start to understand this fact. So see, when I'm in the discovery phase, what I will do is, let us say I am at index 0 comma 1. Okay, you can see this cell here, right? I'm at index 0 comma 1. Now I will try to discover which all land has you know has land, right? That is grid of value is equal to 1, right? So for doing that I will be recursively calling this function to all the four adjacent cells. Okay, this may take me out of the grid. At the same time, it may take me to the cell in the grid which is having water. So for ensuring that I do not, count with those cells, what I'm doing is I'm returning one in this case. Okay. If this is not the case, that means I'm definitely at a cell which is having land. At the same time, it is not visited. Okay. So what I'm doing, if I have, yeah, this is the same thing. If it is already visited, still return 0. Okay. Now I am adding it to my visited set. Okay. I and j are now visited. What I'm now doing, I'm calling the same function in the adjacent cells. Okay. I plus 1 of j, ij plus 1, I minus 1j, and ij minus 1. Okay, these are the cells I'm calling this function into. Okay, now what will happen? If at all I will, face a cell, okay, which is outside this matrix or has a value 0, in that case I'm returning 1. That means this I am reached a end. Okay, that means I am reached the parameter now. Okay, that means this particular cell is going to contribute to the parameter. For that, what I'm doing, if I'm returning 1, okay, that this function will be returning this 1 here. Okay, so this function will, if the return value is 1, okay, that means it is adding to my parameter. Similarly, if this function returns 1, that means it is adding to my parameter. Same is the case for other two cases also. Okay, here also parameter is being added. Okay, and same is here. So one thing, please try to understand this fact: if I am at a cell which is outside this grid or which is water, I am returning 1, because the idea here is the boundary, that is the land next to it, is going to contribute to my perimeter. At the same time, if I am at a land cell, okay, if I am at a cell which is a land, it will return 0. Because why? Because let us say for this part, okay, see this grid, okay, it is basically index 1 comma 1. So in this case, it is not contributing anything to the perimeter, right? Because it is surrounded by land in all four directions. That's why if I am at a land, I will return 0. If I am at a cell which is outside the matrix or has water in it, I will return 1. Okay, as simple as that. At the same time, if let's see, if I'm already visited a land, okay, in that case what I will do, remember it's a land, it's not a water, so still I will have to return 0, because for land I am always returning 0 only. So in this case also I will return 0 only. Okay, I hope you're understanding this part. Let me quickly run this function and show you. And by the way, they've simply clearly mentioned that there's going to be only one island, right? There's going to be only one island. Okay, let me highlight this part. This is exactly one island, right? So what I'm doing here is I am breaking out of this loop, because see, once I've I found a cell with its land, then I will use this function to discover all its adjacent cells. So I do not need to progress with this for loop again. Okay, so this for loop I can simply try to break it out of it. Okay, I can break out of it, as simple as that. So yeah, fine. That's what I'm doing. So I hope you are understanding this part. See, this sounds very simple and tricky, but there is a logic here. See, you will have to dig in this image to understand what is happening. The idea here is, if I'm at a line cell, and if the adjacent cell, okay, diagonal adjacent cell, I'm not saying diagonal adjacent, I'm saying the vertical or the horizontal adjacent cell, right, is a water cell. That means the current land cell on one side is going to contribute to the perimeter. As simple as that. Okay, that's why whenever the return value is 1, okay, whenever the return value is 1, and this function is being checked here, and it's contributing the parameter, that's what it is, right? So let me go and run this function and show you, so that makes sense to you. As you can see, this is passing all the test cases. In all the cases, it is returning the particular answers. So see, the idea is very simple. If I am at a land cell and next adjacent cell, either vertical or horizontal, is a water, that means this particular land cell on one side is going to contribute for the parameter. Okay, so that's why I'm adding 1 to it. Okay, so whenever I am at a cell which is water or outside the grid, I'm returning 1. Whenever I'm at a land cell, either it is already visited, I'm returning 0, or even if it is not visited, still I'm returning 0. As simple as that. So yeah, fine. That was all for this particular video. I know this sounds a bit tricky. I know this because, see, I've did a lot to understand this fact, and that's why I've coded it. I'm sure if you're seeing this for the first time, you will not be able to understand what is happening. That's why I'm saying it. Take this code. I will give this code in the comment section. Go through this question. I will give the link of the question as well in the comment section. Go to this question. Spend some time. Try to understand what is happening, and then come back to the solution. Still, if you are having doubt, again see this video. I'm damn sure that you will understand what is happening, because this code is very, very self-explanatory. Why I'm using this Vester set? The idea is, I should see, when I am this cell, let us say if I am at cell 0 comma 1, okay, I will, in one step I will go below it, right? For exploring process I will go to the cell below it, but when I am in the cell below it for exploring process, I will again come back to the top cell, right? So to avoid that, what I'm doing is, whenever I'm visiting a cell, right, I'm adding it to my set. Okay, so that when this part, if I come back to that set again, so this part will become true, and I will not explore it again. Okay, because it's already explored, right? I will simply return 0 and proceed further. So this is the again part of the set which so I have actually explained to you everything here, whatever is involved in this code. Okay, rest all is up to you. Please spend some time in this question. The idea here is, I can draw many things and show it to you, but the idea here is I want you to discover them. Okay, I can just give you the solution and the ideas. Okay, it is for you to get to the answers, right? If you are having doubts, then only you should be referring this solution, right? And still, if you are not able to understand the solution, spend some time in the code, spend some time in the question, the diagrams, and then come back to this video. I'm sure that you will be finding the answer. So yeah, fine, that was all for this video. I've already summarized the solution and shown it to you. If you have any doubts, please do comment below, and if you like my efforts, please do consider subscribing to my channel. See you tomorrow. Thanks a lot.